Welcome to this session. In this session, we are going to introduce the concept of convolution of functions. And then the next session, we'll do some examples on how to find convolution of functions. So let's see how I work it out. So we start by defining what we mean by convolution of two functions, f and g. Definition. So let f and g be two functions. So we have f of t and g of t are two piecewise continuous functions on the interval 0 to infinity. The convolution of f and g is defined as so this is how we define convolution of two functions f and g. So for two piecewise defined functions on the interval 0 to infinity, convolution of f and g denoted by f star g is given by or defined by f star g in the integral from 0 to t f of t minus v times g of f of v times g of v dv. So let's state some properties of convolution and then state a theorem. So let's have three piecewise defined functions on the interval 0 to infinity. Let f of t, g of t, and h of t be piecewise continuous functions on the interval 0 to infinity. Then we have the following properties. One, that convolution of f and g is the same as convolution of g and f. So commutativity holds. And two, f star g plus h is the same as f star g and then plus f star h. So that's to mean that convolution obeys a distributive property. Number three, if I have f g and then I convolute with h, it's the same thing as taking f, you convolute with g convoluted with h. So that is associative property. And lastly, number four, if you convolute any function f with 0, then you always get 0. And then lastly, let's state convolution theorem without proof. This will help us to solve some problems on convolution. So theorem, or the so-called the convolution theorem. So the convolution theorem says that if we have two piecewise defined continuous functions on interval 0 to infinity, then we have, so let f and g be two piecewise continuous functions. On the interval 0 to infinity. And let the Laplace transform of the function f of s, f of t be given by capital F of s and Laplace transform of this function g of t be given by capital G of t, g of s. So I have two piecewise continuous functions, f and g, on the interval 0 to infinity. And let's their Laplace transforms be capital F and capital G respectively. Then there are two main results. One, if we take the Laplace transform of the convolution of f and g, actually this is a function of s, you get the product of the Laplace transform of f and g. And then or is the same thing as saying if I take the inverse Laplace transform of capital F of S times G of S, this is a function of t, I'll get convolution of F and G. So this number 2. So this result will help us to see how to use convolution to find the inverse Laplace transform of product of two transforms. Thank you. In the next session, we give examples on how to apply convolution and convolution theorem.